talk about measurements and the uncertainty, accuracy, and precision of those measurements. When you're working in a lab, whether it's a biology or a chemistry or physics lab, you may be using pieces of equipment that require you to take actual measurements using the graduation lines that are on those pieces of equipment. An example of that might be a graduated cylinder like what you see here. And when you're measuring using a graduated cylinder, the value that you're going to obtain from that piece of equipment is dependent on the lines that are present on the graduated cylinder. One thing that you need to note is make sure that you read at the bottom of the meniscus of the graduated cylinder, which is essentially this location right here. Before we can actually make the measurement, you need to make sure that you understand what each line represents. And in this particular case, each line in the graduated cylinder is a single 1 millimeter, or milliliter, excuse me. And so because you can actually measure accurately with the line to the ones place in the measurement, you can then add a value to the right of that to that measurement. So that means using this graduated cylinder, we can measure to the tenths place. When you do that on this kind of blown up section over here, what you'll notice is that the bottom of the meniscus is above the line of 21. So we know for a fact that the volume is at least 21. And we can be certain that that ones place is a true value. Where the value starts to get in a little bit of an uncertainty realm is that next number. That is a guesstimation. Because there is no graduation line for you to be able to actually have an accurate value for where the meniscus is at between these two lines, then that particular value is considered an uncertain number. In this particular case, we know it's going to be between 21 and 22, and you'll look and basically estimate what you think it will be. I think it's a little bit above 5, so I'm going to put 6, and then my units behind that number. This particular value gives me significance to the measurement that I'm taking. And one thing that we're going to introduce to you in a later video is values that we call significant figures. Even though the last number given in this reading is uncertain, it is still considered significant to the number as a whole. So in this particular case, each value in this reading is considered a significant figure. Let's translate that to doing a few examples. And in this particular picture, our first graduated cylinder, we need to ascertain which each graduation line represents, and it turns out that they're going to be for every 2 milliliters. And so when we look at the value of the bottom of our meniscus here, we actually move that over, we know that this is going to be 22, 24, and then this is 26. So our value should be somewhere between 24 and 26. We can still report to the ones place accurately. And so with this particular situation, we're going to have to say an estimation somewhere between 24 and 26. I think it's pretty close to being right in the middle, so I'm going to say it's 25, and then I'm going to use my uncertain number, 0. And then we'll put our units behind that. With our second graduated cylinder, each line represents 1 milliliter. Here we're directly on the line here for 9, and remember you can report accurately to what the graduation line is, and then one number past that, so we will put 9.0 milliliters. On this graduated cylinder, each line represents 1 milliliter. And so we can report to the ones place, but then one more decimal past that. So we'll say, since it's directly on that line, 0 milliliters. And here on the fourth graduated cylinder, we're right here on the 20. Each line represents 1 milliliter, so we're in the ones place. This would be 20.0 milliliters. Each one of these numbers, their last digit is considered uncertain, yet it's significant to the value itself. Let's try this with a ruler. And in the ruler, we're going to use this ruler to measure the green line. And we will still do the same kind of situation where the line, we have to determine what that line, the graduations line, mean. And in this particular case, the numbers are represented in centimeters, and each individual little line in between the large long lines are millimeters. So you could technically read this in either centimeters or millimeters. I'm going to go ahead and use centimeters since those are the numbers that are given to us. But note that even though we're at centimeters here, each line is then 1/10 of a centimeter. So right now, we can report to, with accuracy, the tenths place, but we would put an uncertain value past that to the hundredths place. So in this particular case, let's take our kind of line where we think that this measurement moves to, and I think it's in between the 0.6 and 0.7. And so in this particular case, this reading would be 7.6. That's my last certain value. And then my uncertain value is my guesstimation between these two. And I think it's halfway between, so I'm going to say 5. My 5 would be the uncertain value in that number. And then make sure that you put your units past that. So let's try that one more time with the ruler. We know that the same kind of graduation lines for the ruler above. This would be a measurement of, can I go down there a little bit? 3 point, and then we go 5, 6, 7, 8. That's for certain. And then beyond that, I guesstimate, and I think probably maybe 3. And then centimeters. So those are how you use graduation lines to make measurements using a device that has analog type values, which means you're not getting a digital readout. The last thing that I wanted to talk a little bit about is you are actually going to be using scales in a lab. And typically in the modern labs, we have digital scales. And I put here a couple of pictures of scales that have different certainty readouts of their scales. So this particular scale goes to 1 decimal place, the tenths place. This scale goes to the hundredths place, and then this scale goes to the thousandths place. If I were going to measure something that was 1 gram, and I know it was 1 gram, and I put it kind of like a little cylinder of 1 gram of some metal, how I would read that on this scale is 1.0 grams. And I am certain that these values are significant because the scale gives me that readout. The last digit would be analogous to the last digit in your readouts from the graduated cylinder and ruler, where it's the most uncertain out of that, but still significant. In the middle scale, if you measured 1 gram, it would be 1.00 grams, where this number right here, the tenths place, is certain, but the hundredths place is the uncertain number. All 3 would still be significant, however. On the last scale, it'd be 1.000 grams, where all numbers except for the last one would be certain, and the last 0 would be our most uncertain value, yet still significant, all 4 numbers. So this is how you do readings from a digital piece of equipment. The last thing that I wanted to talk a little bit about was this vocabulary term, accuracy and precision. It turns out that in science we do a lot of repetition. And the reason why we do repetition of a particular task of taking measurements is because we want to ensure that the measurements that we are doing are accurate and precise. So the definition of accurate means that you're actually getting close to the true certain value. So if you were here in this kind of bullseye diagram, if you're hitting the center of that diagram, that is considered accurate. If all of your readings, which if you can see here, all 3 of these particular little black dots are also together, we would consider that precise. Precise means you're getting the same kind of value every time that you're taking a reading. Over here on the second one, you can see that these are still clustered together. They're precise, but they're not in the center, so we would say they're not accurate. And none of these are clustered or in the bullseye, so they're not accurate, not precise. I hope this helps. And leave me any comments if you have any comments, or bring questions to class next time we see each other.